apple. In the darkest corners of the universe, there is a substance that acts like a plague on everything. It creates itself by absorbing everything it touches. If a single drop of it fell on an apple, for example, it would turn into a sphere heavier than a skyscraper. It would melt the floor, fall into the center of the earth, and in a matter of minutes turn it into a hot, dead rock. But what happens if this particle gets inside you? Tonight, we'll look at the most dangerous object in physics. We'll track invisible bullets flying through our solar system right now. We'll search for sleeping mines accumulating under our feet, and we'll meet scientists who are trying to create this nightmare in the laboratory. So, let's begin. To understand why a simple piece of fruit can suddenly turn into a weapon of mass destruction, we have to look at how wasteful ordinary matter actually is. Every atom in your body, in the chair, and in the concrete walls is composed almost entirely of empty space. The nucleus of an atom is like a small marble sitting in the center of a large football stadium, and the electrons are the fans sitting in the furthest row of seats. Everything between the marble and the fans is a void, kept inflated only by the energetic motion of the particles. We are walking clouds of vacuum that only feel solid because our electrons push against other electrons. The particle of strange matter that hit the apple works like a cosmic vacuum pump that removes this wasted space. It does not respect the rules that keep the electrons far away from the nucleus. It grabs the fans and pulls them directly into the marble, collapsing the stadium down to the size of the marble itself. This process is called conversion, and it is the most efficient energy source in nature. When the apple collapses, it isn't just getting smaller, it is releasing the energy that was used to keep the stadium inflated. This is known as binding energy. In a nuclear bomb, we split atoms to release a fraction of this energy, which is messy and leaves behind radioactive waste. But strange matter does not split the atom, it optimizes it. It merges the protons and neutrons into a single, seamless block of matter, releasing a level of heat that makes a nuclear explosion look like a matchstick. The grain of sand that used to be an apple is now radiating gamma rays and thermal energy with such intensity that the air in the room instantly turns into plasma. This heat is not a chemical fire that needs oxygen. It is the raw scream of matter being crushed into a lower energy state. The stability we rely on is simply a high energy trap, and the strange matter is the door opening to the basement. Once the door is open, the atoms surrounding the apple, the molecules of the air, the varnish on the table, sense this lower energy state and rush to join it. They are not destroyed, they are assimilated. They fall into the dense sphere, adding their mass to it, and in doing so, they release their own binding energy, fueling the fire even further. Gravity is a weak force when dealing with normal objects, which is why a table can easily support the weight of a fruit. But density changes the rules of engagement. The object that replaced the apple is now millions of times denser than lead, concentrating the mass of the fruit into a point so sharp that the structural integrity of the table effectively ceases to exist. The wooden surface does not splinter or crack in a way we would recognize. The Strangelet passes through the wood fibers as if they were made of mist. The object begins to fall. It hits the floor of the room. If the floor is made of concrete reinforced with steel bars, it offers no resistance. The steel bars are made of atoms that are 99% empty space, and the falling sphere is a solid block. It shears through the metal molecular bonds without slowing down, converting the steel into more strange matter as it passes, adding micrograms to its mass and brightness to its heat. It melts a perfectly vertical tunnel through the foundation of the building, moving faster with every second as gravity pulls it toward the greatest source of mass available. The building above does not collapse immediately from the hole, but from the shock wave of the heat left behind. The air in the tunnel expands explosively, shattering the concrete from the inside out. Meanwhile, the object enters the soil. It passes through the dirt, the clay and the bedrock of the city. It is now a falling star beneath the ground. It does not stop. There is no rock hard enough to halt its descent because every rock it touches becomes fuel. It is falling toward the center of the Earth, and the planet is completely defenseless against it. The terrifying aspect of this descent is not the fall itself, but the growth rate of the object. When a fire burns in a forest, it is limited by the surface area of the timber and the supply of oxygen, meaning it can only grow as fast as the wind pushes it. Strange matter has no such limits because it does not need oxygen, and its fuel is the entire planet. The mathematics of this growth are governed by a simple, brutal power law. The more matter the object eats, the larger its surface area becomes, and the larger the surface area, the more matter it can eat in the next second. As the object sinks through the Earth's mantle, it encounters dense magma and rock. This is an all-you-can-eat buffet for the Strangelet. It grows from the size of a sand grain to the size of a marble, then a golf ball, then a bowling ball. With every doubling of its size, the conversion zone, the mouth of the object, expands. The heat generated by this process melts the surrounding rock, thousands of meters ahead of the object, turning the solid mantle into liquid magma that flows rapidly into the conversion zone. This creates a suction effect. The Strangelet is no longer just falling, it is actively inhaling the planet. This is not a chemical explosion that pushes material away. It is a gravitational implosion that pulls material in. The Earth is being eaten from the inside out, and the waste product of this digestion is pure heat. A shockwave of thermal energy begins to race upward through the tunnel created by the fall, moving back toward the surface. The ground beneath the city where the apple first fell begins to warm up. Then it begins to smoke. Then the pavement starts to glow red. The fire is not coming from the sky, it is coming from the rocks beneath your feet, which are conducting the thermal scream of the dying core. Within minutes, the object reaches the Earth's core. Here, the density of iron and nickel provides the ultimate fuel source. The Strangelet, now perhaps the size of a large building, settles in the gravitational center of the planet and begins to feed in all directions simultaneously. It acts like a drain in a bathtub. The liquid iron of the outer core swirls down into the event horizon of the strange matter, flashing into gamma radiation as it crosses the boundary. The structural integrity of the planet depends on the pressure of the core pushing outward against the weight of the crust. But as the core is converted into the strange matter, its volume decreases by a factor of millions. The pressure vanishes. The support struts of the planet are removed. The Earth's crust, the thin layer of rock we live on, suddenly realizes it is floating over a void. Gravity demands payment. The crust buckles. Tectonic plates that have been stable for millions of years snap like dry twigs. Entire continents begin to slide inward. The oceans do not boil away immediately. They simply fall into the cracks opening in the ocean floor, pouring trillions of gallons of water into the subterranean furnace. The atmosphere, no longer held up by a stable surface, rushes into the depression, creating supersonic storms with wind speeds higher than any hurricane in history. The sky literally falls. From the perspective of a satellite, the Earth would not look like it is exploding. It would look like it is shriveling, shrinking rapidly as the blue marble collapses into a tiny, blindingly bright point of light. When the screaming stops, silence returns to the solar system, but the view has changed fundamentally. Where the blue marble of Earth once floated, there is now a dark, terrifyingly small object orbiting the sun. The entire planet, the oceans, the crust, the atmosphere, and the 6 billion years of biological history has been compressed into a sphere roughly 100 meters in diameter. This object is not a black hole. It reflects light, it has a surface, and it is physical. It is a hot, radiating marble composed entirely of strange matter. This new object retains the exact mass of the original Earth, meaning its gravitational pull on the moon remains mathematically identical. The moon continues to orbit this tiny, invisible point in space as if nothing happened, ghosting around a graveyard. However, the surface conditions of this strange Earth are radically different. It is spinning at a rate of thousands of revolutions per second, conserving the angular momentum of the original planet but confined to a much tighter radius. It glows with a fierce, lethal X-ray luminosity, radiating the residual heat of the conversion process into the vacuum. This sphere is the most stable object in the local universe. It is impervious to change. If you were to fire a nuclear weapon at it, the bomb would not scratch the surface. The nuclear material would simply be absorbed upon contact, converted into more strange matter, and added to the mass of the sphere. It does not rust, it does not decay, and it does not age. It is a perfect, eternal monument to the physics of optimization. The chaos of biology, the complexity of cities, and the turbulence of weather have all been corrected into a uniform, featureless block of subatomic soup. This is the endpoint of the scenario. It is not an explosion that leaves debris. It is a formatting error that wipes the hard drive clean, leaving only a blank, spinning disk. This scenario sounds like the product of a paranoid science fiction writer, and for a long time, it was. In 1963, the author Kurt Vonnegut published Cat's Cradle, a novel that introduced the world to the concept of Ice Nine. In the book, Ice Nine was a fictional form of water that froze at room temperature. The horror of the story came from the idea of a seed crystal. If a single crystal of Ice Nine was dropped into the ocean, it would teach the surrounding water molecules to arrange themselves in this new, frozen pattern. The reaction would spread instantly, freezing all the oceans on Earth and locking the planet in eternal winter. Vonnegut meant it as a satire on nuclear weapons, a metaphor for how a single technological error could end history. But physics has a dark sense of humor, and it often turns satire into reality. In the 1970s and 80s, theoretical physicists realized that the mathematics of the strong nuclear force allowed for a material that behaves exactly like Ice Nine, but instead of freezing water, it freezes atoms. They called these particles strangelets. A strangelet is a small fragment of strange matter that acts as a nucleation site, a seed. The difference between Vonnegut's fiction and the physicist's reality is strictly thermodynamic. Ice Nine turned water into ice, releasing a small amount of heat. Strangelets turn matter into plasma, releasing the energy of 1,000 suns. The mechanism, however, is identical. It is a contagion of information. The strangelet carries a set of instructions that tells the atomic nucleus, there is a better way to be packed. And because the laws of the universe drive everything towards stability, the nucleus has no choice but to obey. The terror of the strangelet is not that it destroys matter, but that it improves it to the point of incompatibility with life. It solves the problem of existence by removing the complexity that makes existence possible. It is easy to dismiss this as a cosmic problem, a disaster that happens to planets in abstract simulations. You might feel safe because you assume that your body is a private, isolated system. But this is a cognitive bias. The danger of strange matter is not about the size of the planet. It is about the architecture of the atom. The very same protons and neutrons that make up the Earth also make up the cells of your heart, the neurons in your brain, and the DNA in your blood. You are built from the same fuel that burned the world in our scenario. The only reason you are not currently collapsing into a microscopic speck of super-dense plasma is a fragile energy barrier. Your body is essentially a walking battery, storing a massive amount of potential energy in the tension of your atomic nuclei. You are not a solid object. You are a collection of forces pushing against each other, maintaining a delicate standoff. The strangelet is simply the spark that ends the standoff. This shifts the fear from the astronomical to the biological. We are not just living on a planet that can be eaten. We are made of the food. Every second of your life, your atoms are fighting a silent battle to maintain their shape against a universe that would prefer them to be collapsed. We are not the standard setting of reality. We are a high-energy anomaly, a teetering tower of blocks waiting for a reason to fall. To understand why we are so vulnerable, we have to zoom in past the skin, past the cell, and look directly at the chaotic, terrified machinery inside a single proton. If you could look inside the nucleus of a hydrogen atom, you would not see a calm, solid sphere like the pictures in a high school textbook. You would see a frantic, violent cage match. A proton is composed of 3 fundamental particles called quarks, 2 up quarks and 1 down quark. These quarks are bound together by the strong nuclear force, carried by particles called gluons. The gluons act like rubber bands, constantly snapping the quarks back together whenever they try to drift apart. This system is defined by extreme tension. The quarks are moving at near the speed of light, desperate to escape, but the rubber bands of the gluon field hold them trapped in a volume smaller than a femtometer. This confinement requires immense energy. In fact, 99% of the mass of a proton, and therefore 99% of your body weight, does not come from the quarks themselves, but from the kinetic energy of this struggle. You are literally made of stress. Nature generally hates stress. The laws of thermodynamics dictate that all systems seek the lowest possible energy state, the ground state. Water flows downhill to reduce gravitational potential. Hot coffee cools down to reduce thermal potential. Yet, the proton remains high on the energy ladder, vibrating with suppressed fury. It is stuck in a local minimum, a valley that is low enough to exist, but not the lowest point on the map. It survives only because of a quantum rule called the Pauli exclusion principle, which prevents the quarks from occupying the same space, forcing them to keep their distance and maintain the tension. But rules in quantum mechanics are not walls, they are merely high fences. And if something were to open a gate, the quarks would rush to a lower, more comfortable state instantly. In 1984, the physicist Edward Witten, one of the most brilliant minds in the history of string theory, proposed a disturbing solution to this atomic anxiety. In a seminal paper titled Cosmic Separation of Phases, he suggested that the proton is not the final form of matter. He argued that if you were to take a soup of quarks and add a third ingredient, the strange quark, the rules of the game would change fundamentally. Strange quarks are heavier than up or down quarks, which usually makes them unstable. However, Witten calculated that in a dense enough mixture, the addition of strange quarks actually lowers the total energy of the system. This happens because of the exclusion principle. Think of it like a crowded bus. If there are only 2 types of passengers, up and down, the seats fill up quickly and everyone has to stand uncomfortably. But if you introduce a 3rd type of passenger, strange, you effectively open up a 3rd row of seats. The particles can pack themselves much tighter without violating the laws of physics. This tighter packing creates what is known as the true ground state. In this state, the rubber bands of the gluons relax. The tension vanishes. The quarks settle into a perfect, low-energy lattice. This material, strange matter, is not holding its breath like a proton. It is exhaling. It is the absolute bottom of the energy hill. Witten's hypothesis implies that the entire periodic table of elements, hydrogen, carbon, gold, oxygen, is merely a metastable mistake. We are the foam on top of the ocean, believing we are the water. The strange matter is the deep, still ocean beneath us, and gravity is constantly pulling us to pop and join the depths. The driving force behind every event in the cosmos, from a falling rock to a dying star, is a fundamental laziness. The universe hates to exert itself, and it is constantly trying to shed energy to reach a state of absolute rest. Think of a ball sitting at the top of a steep hill. It has the potential to roll down, and gravity is constantly pulling at it, begging it to fall so it can stop holding onto that potential energy. This desire to fall is what physicists call seeking the ground state, and it dictates the fate of everything. Water flows downhill to find its ground state in the ocean, and hot coffee releases heat to find its ground state in the cold air of the room. However, the atoms that make up your body, the chair, and the planet are not in the ocean. They are stuck on a jagged ledge halfway down the cliff. We assumed for a long time that protons were the bottom of the hill, the most relaxed and stable form of matter possible. But the mathematics of the strange quark suggest that we are wrong. We are not at the bottom. We are balancing precariously on a high shelf, vibrating with excess energy that we cannot get rid of. Below us, deep in the valley of energy, lies the true ground state, strange matter. This substance is the ocean at the bottom of the cliff. It is the form of matter that the universe actually wants to be. The tension inside our atoms exists because they are frantically trying to maintain their complex shape against a natural law that prefers simplicity. We are holding a difficult yoga pose while strange matter is lying comfortably on the couch. Consequently, the entire structure of our reality is just a temporary, exhausting effort to avoid becoming what physics wants us to be. The universe is patient and it is waiting for us to get tired and slip. If the universe is so desperate to turn us into strange matter, a terrifying question arises. Why haven't we fallen off the ledge yet? Why does the apple on your desk stay an apple instead of instantly collapsing into a pile of subatomic sludge? The answer is that we are protected by a wall. In physics, this is known as an energy barrier, but you can think of it as a massive concrete dam holding back a lake. The water in the lake wants to flow down to the valley, but the dam is too thick and too high for the water to cross on its own. Our atoms are the water, and the laws of quantum mechanics are the dam. Specifically, the electrical repulsion between atomic nuclei acts as a shield that prevents protons from getting close enough to trigger the collapse. This shield is incredibly robust. It is held up for 13.8 billion years, allowing stars to burn and life to evolve in the safety of the reservoir. We look at the age of the universe and mistake this longevity for permanent safety, assuming that because the dam hasn't broken yet, it never will. But a dam does not need to crumble completely to fail. It only needs a single crack. The Strangelet is that crack. It doesn't need to overpower the entire wall. It simply offers a shortcut through it. If a Strangelet touches a normal nucleus, it negates the electrical shield because it is heavier and more powerful than the forces holding the dam together. It opens a small drain in the concrete. Once the first drop of water finds the hole, the pressure of the entire lake forces the gap to widen. The barrier that protected us for billions of years is rendered useless not by brute force, but by a trick of geometry that turns our own energy against us. The way this collapse spreads is not through an explosion, but through a process that looks suspiciously like a contagion. In the biological world, there are proteins called prions that act as architects of death. A prion is a twisted, broken molecule that has no DNA and no life, yet when it touches a healthy protein in the brain, it physically forces the healthy one to twist into the same broken shape. The victim becomes the killer, turning around to infect its neighbors in a silent, exponential wave of corruption. Strange matter behaves exactly like a cosmic prion. It is a zombie state of particles. When a Strangelet touches a normal atom, it doesn't destroy the protons and neutrons. It teaches them a new way to arrange themselves. It effectively says, stop struggling to hold that shape. Come down here where it's easier. The protons, governed by the laziness of the universe, immediately accept the offer. They dissolve their boundaries and merge into the Strangelet, adopting its properties and adding their mass to its bulk. This creates a chain reaction of peer pressure on a subatomic scale. The first infected atom becomes part of the Strangelet, increasing its size and its gravitational pull, which allows it to grab the next atom even faster. It consumes the apple, not by burning it, but by converting it. The terrifying part of this mechanism is that it is 100% efficient. There is no waste, no smoke, and no leftovers. Every single particle that is touched joins the collective. It is a perfect assimilation machine that turns the diversity of the periodic table into a single, uniform mass of obedient matter. The ultimate horror of this conversion is the total erasure of identity. In our world, structure is everything. The difference between a breath of oxygen and a cloud of poison gas is simply the number of protons in the nucleus. The difference between a block of gold and a block of lead is just a minor arithmetic shift in the atomic structure. This variety allows for chemistry, for biology, and for the complex machine that is your brain. We exist because matter can be arranged in billions of different distinct patterns. Strange matter is the end of patterns. It is a blender that takes the intricate Lego castle of the universe and grinds it down into a solid block of plastic. Inside a lump of strange matter, there are no elements. There is no carbon, no iron, no oxygen. There are only quarks swimming in a featureless soup. The Strangelet does not care if it is eating a masterpiece painting, a nuclear warhead, or a living human being. It breaks them all down into the exact same raw ingredients. If the Earth were converted, the resulting sphere would be a monotonous tomb. It would not have a crust, a mantle, or a core. It would not have mountains or trenches. It would be a perfectly smooth drop of liquid density, identical from surface to center. The history of the planet, the fossil record, and the evidence of our civilization would not just be destroyed, they would be formatted. The information that made us would be deleted, replaced by a substance that has no memory and no future, only an eternal, unchanging present. From the cold perspective of physics, however, this blank slate is not a tragedy, it is perfection. Ordinary matter is weak, it decays over time, it breaks under pressure, and it falls apart in nuclear reactions. It is mortal. Strange matter is the diamond of the subatomic world. Because it sits at the absolute bottom of the energy valley, there is nowhere lower for it to go. It cannot decay. It cannot rust. It cannot die. Once a Strangelet is formed, it is essentially indestructible. If you were to throw it into the heart of the sun, it wouldn't melt. It would drink the sun. If you blasted it with a nuclear bomb, it would just absorb the energy and grow slightly larger. It is immune to time. While stars burn out and galaxies drift apart, a sphere of strange matter will remain exactly as it is, spinning in the dark for trillions of years. This suggests that the universe is not hostile to us. It is simply trying to finish a job. We are the scaffolding, the messy, temporary structure used to build the final product. Strange matter is the monument that remains after the scaffolding is taken down. The silence of the night sky might be the result of this process. It is possible that the galaxy is already full of these perfect, silent graves, ancient worlds that reached the ground state and simply stopped participating in the chaotic struggle of existence. But to find out where these graves come from, we have to look for the factories that build them. If strange matter is the perfect, preferred state of the universe, a rational question follows. Why isn't the universe already made of it? Why are we still messy bags of carbon and water instead of perfect spheres of strange quarks? The answer lies in the difficulty of manufacturing perfection. Nature operates like a blacksmith who knows that the strongest steel requires the hottest fire. You cannot create a diamond by simply asking a piece of coal to change its shape. You have to crush it under the weight of a mountain until the atoms have no choice but to rearrange themselves. Strange matter requires a similar forge. In the vacuum of space or on the surface of a planet, atoms are too far apart to interact in the necessary way. They are protected by their electron clouds and the vast distances between nuclei. To force protons and neutrons to dissolve into a quark soup, you need to overcome the forces that hold them apart. You need a pressure so extreme that it breaks the fundamental laws of structural integrity. You need to squeeze matter until the concept of empty space becomes a physical impossibility. The universe does not have many places capable of exerting this kind of force. It requires a gravity well deep enough to crush atoms like soda cans. For billions of years, a star fights against this crushing force using the heat of nuclear fusion, pushing outward to keep its shape. But eventually, the fuel runs out. The fire dies. Gravity, which never sleeps and never needs fuel, instantly wins the war. The star collapses in on itself, and in the ruin of that collapse, the conditions for strange matter are finally met. The factory is open for business. When a massive star dies, it does not just fade away, it violently implodes. The outer layers are blown off in a supernova, but the core, the heavy iron heart of the star, is left behind. This core is heavier than our sun, but gravity squeezes it into a sphere the size of a single city. This object is a neutron star, and it is the densest material object in the cosmos that still has a surface. The environment on a neutron star is beyond human comprehension. The gravity is 100 billion times stronger than on Earth. If you were to drop a marshmallow on the surface, it would hit with the energy of a nuclear warhead. Under this crushing weight, the atoms that make up normal matter simply give up. The electrons, which usually orbit the nucleus at a safe distance, are physically shoved into the protons. The positive and negative charges cancel out, and the entire star turns into a ball of neutrons. This is a dead star. It is a corpse that is being compressed by the weight of its own failure to burn. The neutrons are packed shoulder to shoulder, holding the star up with a quantum rule called degeneracy pressure. It is a desperate, final scaffolding preventing the star from collapsing into a black hole. But in the hearts of the most massive neutron stars, even this scaffolding begins to creak. The pressure in the center rises higher and higher, pushing the neutrons closer than physics should allow until they are overlapping. The walls of the neutrons themselves begin to buckle. Deep in the core, the density reaches a critical point where individual particles can no longer exist. A neutron is not a solid ball, it is a bag containing 3 quarks. When the pressure becomes high enough, the bags burst. The boundaries that separate one neutron from another dissolve, and the contents spill out. The core of the star ceases to be matter as we understand it, and becomes a liquid. This substance is called quark-gluon plasma. It is a chaotic, boiling soup of particles that haven't been free since the first microsecond of the Big Bang. In this state, the quarks are confused. They are packed so tightly that they lose their identity. They are frantic, moving at relativistic speeds, colliding with their neighbors, and vibrating with the heat of the collapse. But this chaos is unstable. The system is still too high on the energy curve. It is looking for a way to cool down, a way to organize the mess. Nature finds a solution in the strange quark. In standard matter, quarks are light. But the high-pressure environment of the core makes it energetically expensive to be light and fast. It actually becomes cheaper for the system to turn some of these light quarks into heavy, strange quarks. It seems counterintuitive, like packing a suitcase with bricks instead of feathers to save space. But in quantum mechanics, heavier particles can sometimes pack more efficiently. The star begins to perform alchemy on itself, transmuting its own substance into a new form of matter that is stable, heavy, and absolutely calm. This conversion is the birth of the strange star. As the quarks flip into their strange state, the energy of the system plummets. The core settles into the true ground state we discussed earlier. This new strange matter core is rock solid and invincible, but the process doesn't stop at the center. The strange matter is contagious. It touches the layer of neutrons above it and converts them. It eats its way outward, consuming the star from the inside out. The star essentially becomes a cannibal. The strange core grows, swallowing the mantle of neutrons, turning the entire object into a single, giant crystal of strange matter. The enormous energy released by this conversion blasts outward as a flood of neutrinos, cooling the star almost instantly. What remains is no longer a neutron star. It is a strange star, a single, city-sized atomic nucleus held together not just by gravity, but by the strong nuclear force itself. This object is a monster. It has a surface that is harder than steel by a factor of billions. It can spin 1,000 times a second without flying apart. And crucially, it is sitting in the dark void of space, holding the most dangerous substance in the universe within its gravitational grip. It is a loaded gun. As long as the star remains intact, the strange matter is trapped, bound by gravity to the sphere. But stars do not always remain intact. Sometimes they crash. The terrifying part of this theory is that we may have already found one of these monsters. Astronomers do not need to touch a star to know what it is made of. They just need to watch how it dies. A standard neutron star is hot, and because it is surrounded by a vacuum, it should act like a thermos, holding onto its heat for millions of years. It should cool down very, very slowly. However, when NASA's Chandra X-ray Observatory pointed its mirrors at the supernova remnant Cassiopeia A, it saw something impossible. The neutron star at the center of the cloud was cooling down rapidly, dropping in temperature by 4% in just 10 years. In astronomical terms, this is not cooling. This is freezing to death in real time. A standard ball of neutrons cannot lose heat that fast. The laws of thermodynamics forbid it. The only physical process capable of stealing heat that quickly is the creation of strange quarks. The rapid cooling is the thermal signature of a star that is actively dissolving its own neutrons and turning them into strange matter. The neutrinos produced by this conversion carry the heat away, leaving the corpse cold. We are looking at a crime scene where the body is still warm, and the evidence points to a transformation that shouldn't be possible. The factory is real. It is running. And every time two of these factories collide, they don't just destroy each other. They scatter their product across the galaxy. The strongest evidence for the existence of strange matter comes from a simple measurement of geometry. In physics, size is not an aesthetic choice. It is a rigid consequence of the forces inside an object. A neutron star is held up against gravity by the mutual repulsion of its neutrons. This force, called neutron degeneracy pressure, has a physical limit. It dictates that a neutron star cannot be smaller than about 12 kilometers in radius. If you squeeze it any tighter, the neutrons must overlap, which violates the laws of quantum mechanics for normal matter. However, the universe does not always obey our textbooks. When astronomers turned the Hubble Space Telescope toward a star named RxJ 1856, located just 400 light-years from Earth, they found a problem. Based on its thermal radiation and distance, the star appeared to be far too small. Its radius was calculated to be somewhere between 6 and 8 kilometers. This is physically impossible for a ball of neutrons. A neutron star of that size should collapse into a black hole or explode. The fact that RxJ 1856 exists and is stable implies that it is made of something much denser than neutrons. It implies that the particles inside are packed so tightly that they have dissolved into a quark soup. Only strange matter has the necessary density to explain this object. The quarks can sit closer together than neutrons, allowing the star to be smaller without collapsing. This tiny dark sphere is likely a strange star, a macroscopic object made entirely of the dangerous substance we fear. It sits there in the darkness, a silent, heavy proof that the conversion process is not just a theory. It has happened, and the result is sitting in our galactic backyard. If these stars are made of contact infectious matter, you might ask why they haven't converted the rest of the galaxy yet. Why doesn't the interstellar gas touching the surface of RxJ 1856 turn into strange matter and spread the infection outward like a shockwave? The answer lies in the intense gravity of the star itself. Gravity acts as the ultimate quarantine officer. It pulls everything heavy downward with such violence that nothing can escape the surface. Furthermore, strange stars are likely disguised. Theoretical models suggest that a strange star is not a naked ball of quarks. It is covered by a thin skin of ordinary matter, mostly iron and carbon, floating on top of the quark ocean like a layer of oil on water. This crust is held up by the extreme electric fields generated at the surface of the strange matter. To an outside observer, or even to a passing gas cloud, the star looks and acts like a normal neutron star. The danger is completely contained beneath this metallic shell. This containment system is perfect, as long as the star remains isolated. The strange matter is locked in a gravitational prison, unable to reach out and touch anything. The crust acts as a buffer zone, preventing the core from interacting with the universe. But the universe is a dynamic, violent place. Stars do not always float alone in the void. They exist in pairs, orbiting each other, spiraling inward over billions of years, destined for a collision that will shatter the crust and release the prisoner. Gravity is relentless. In a binary system where two neutron stars orbit each other, they constantly lose energy by radiating gravitational waves. This loss of energy causes their orbits to decay. They spiral closer and closer, spinning faster and faster until they are moving at a significant fraction of the speed of light. Eventually, the centrifugal force and tidal gravity become so strong that the stars are torn apart seconds before they touch. When they finally collide, the energy release is cataclysmic. This event is called a kilonova. It is a messy, chaotic explosion that creates conditions hotter and denser than the Big Bang. In this fraction of a second, the containment fails. The crust of the stars is obliterated. The strange matter cores smash into each other, splashing their contents out into the vacuum of space. Most of this material is instantly swallowed by the black hole that forms in the aftermath of the crash. But the physics of the collision dictates that a significant amount of debris is ejected outward at escape velocity. These are the splashes of the Quark Ocean. Trillions of tons of strange matter are ripped free from the gravitational prison and flung into the void. Freed from the crushing pressure of the star, these fragments do not revert to normal matter. They cool down and crystallize into stable, independent droplets. The quarantine is broken. We know these collisions happen because we have heard them. On August 17th, 2017, the LIGO detectors on Earth picked up the gravitational ripple of a kilonova named GW 170817. It was the first time humanity had ever witnessed the collision of two neutron stars. Astronomers celebrated this event because the spectrum of light from the explosion confirmed a long-held theory. These crashes are the factories where the universe makes its heavy elements. The gold in your wedding ring, the platinum in your catalytic converter, and the uranium in our bombs were all forged in the fire of a kilonova. We look at this event as a creative force, a cosmic goldmine that enriched the galaxy. But the strange matter hypothesis adds a shadow to this discovery. If these collisions produce gold by spraying neutrons into space, they also produce strangelets by spraying quark matter. Mixed in with the clouds of precious metals expanding from the crash site are trillions of microscopic seeds of strange matter. This changes the narrative of the kilonova from a beautiful forge of creation to a dirty bomb. The explosion acts as a shotgun blast, scattering infectious shrapnel in all directions. The gold dust eventually clumps together to form planets and asteroids, carrying the strangelets with it. It is possible that the very process that seeded Earth with the heavy metals necessary for civilization also seeded it with the dormant agents of its destruction. We are sifting through the debris of a catastrophe, delighted by the shiny metal, unaware of the poison hidden inside the dust. The debris from a kilonova does not stay local. The fragments are ejected at speeds approaching 30% of the speed of light. In the vacuum of space, there is no air resistance to slow them down. A strangelet launched from a collision a billion years ago is still traveling today, crossing the vast distances between stars like a silent, invisible bullet. These projectiles come in all sizes. Some are macroscopic, the size of a boulder or a mountain, but the vast majority are microscopic, roughly the size of an atomic nucleus or a virus. Despite their small size, their density is absolute. A strangelet the size of a pollen grain would weigh tons. This density makes them unstoppable. If such a particle were to hit a star, it would punch through the outer layers without slowing down. Physics predicts that these strangelets are stable at zero pressure. This means they do not need the gravity of a star to hold them together anymore. They are cold, solid, and eternal. They drift through the spiral arms of the Milky Way, completely invisible to our telescopes, because they do not emit light and are too small to block the light of stars behind them. The galaxy is effectively a shooting gallery where the bullets never stop moving. We are not living in empty space. We are living in a crossfire that has been accumulating ammunition for 13 billion years. The most disturbing aspect of this threat is not that it exists, but that we are completely blind to it. Astronomy is a science of light. We find planets because they reflect sunlight. We find stars because they burn, and we find black holes because they eat light. If an object does not emit radiation and is too small to block the background stars, it is effectively invisible to every instrument humanity has ever built. A Strangelet is the ultimate stealth object. It is cold, roughly the temperature of deep space, so infrared telescopes look right through it. It is incredibly small. A fragment the mass of a mountain might be smaller than a red blood cell, so it doesn't occult distant stars. Even if a Strangelet the size of a car were drifting through our solar system right now, we would have absolutely no way of knowing it was there until it hit something. This invisibility transforms the vacuum of space from an empty void into a potential minefield. We assume that if we look up and see nothing, then nothing is there. But this is a selection bias of our biology and our technology. We are like a submarine navigating a dark ocean without sonar, assuming the water is clear simply because we haven't crashed yet. The strange matter hypothesis suggests that the dark matter holding galaxies together, the invisible mass that outweighs visible stars 5-1, might actually be clouds of these strangelets. If that is true, we aren't just looking for a needle in a haystack. We are swimming in a sea of needles. The scale of this minefield is dictated by time. The Milky Way galaxy is approximately 13.6 billion years old. Over that vast stretch of deep time, millions of generations of stars have lived, died, collided, and sprayed their contents into the interstellar medium. The debris from these catastrophes does not evaporate. Strange matter is stable, so it persists forever. This means that the density of strangelets in the galaxy is cumulative. Every kilonova that has ever happened adds more shrapnel to the pile. It is a slow, relentless pollution of the cosmos. The space between the stars is not empty. It is dusty with the heavy, invisible ash of dead worlds. Calculations based on the rate of neutron star collisions suggest that the flux of strange matter through our region of the galaxy could be significant. It is not a storm, but a steady drizzle. While the odds of a direct hit on a small target like a human are vanishingly low, the odds of a hit on a large gravity were like a planet approach certainty over geological timescales. We look at the cratered surface of the moon and see the history of asteroid impacts, rocks that we can see and track, but we do not see the history of the other impacts. The ones that left no craters because the projectile was smaller than a grain of sand and punched through the rock without exploding. We tend to think of the solar system as a static house sitting in a quiet suburb of the galaxy. In reality, the sun is a vehicle moving at 220 kilometers per second, dragging the Earth and other planets along with it. We orbit the center of the Milky Way once 230 million years. This orbit takes us through different environments, dense spiral arms, clouds of molecular gas, and regions where ancient star clusters have detonated. This motion turns the Earth into a scoop. We are constantly sweeping through new volumes of space, effectively trawling for debris. Every second, the Earth occupies a cylinder of space that was empty a moment ago. If there are strangelets drifting in the void, we are running into them face first. The windshield of a car moving on a highway eventually hits a bug, no matter how few bugs there are, simply because the car keeps moving. The Earth has been driving on this galactic highway for 4.5 billion years. It is statistically improbable that we have dodged every single bullet. The question is not if we have been hit, but when and how often. And if we have been hit, why are we still here? Why hasn't the planet collapsed into a hot sphere of quarks? The answer lies in the interaction between the bullet and the target. When a normal meteor hits the Earth's atmosphere, it slams into a wall of air molecules. Friction heats the rock, causing it to glow, burn, and often disintegrate before it hits the ground. This is our planetary shield. We rely on the atmosphere to burn up the trash falling from the sky. But a Strangelet does not care about air. It is millions of times denser than rock, denser even than the nucleus of an atom. To a Strangelet, the atmosphere is less than a mist. It passes through the air molecules without slowing down, without heating up, and without creating a sonic boom that we would notice. The shield of the atmosphere is totally transparent to it. A Strangelet hitting the atmosphere is like a needle passing through smoke. It retains 100% of its kinetic energy. It strikes the surface of the ocean or the ground at cosmic velocities, tens of thousands of miles per hour. And because it is so small and dense, it doesn't splash or crater in the traditional sense. It punctures. It enters the crust of the Earth as easily as it entered the vacuum of space, leaving a microscopic tunnel that is instantly sealed by the pressure of the rock around it. The entry is silent. Here is the paradox. The immense speed of the Strangelet is exactly what saves us. For the Ice-9 reaction to start, the strange matter needs to capture a nucleus, slow it down, and absorb it. But capture takes time. It relies on the interaction between the Strangelet's charge and the atom's electrons. When a Strangelet is moving at 200 kilometers per second, it spends only a tiny fraction of a femtosecond inside any given atom. It is moving too fast for the nuclear forces to grab onto the surrounding matter. It is a clean shot. It tears through the electron clouds and passes by the nuclei before the reaction can ignite. Think of it like moving your hand through a candle flame. If you move your hand fast enough, you don't get burned because there isn't enough time for the heat to transfer to your skin. The Strangelet is the hand, and the Earth is the flame. It punches through the crust, flies through the mantle, pierces the core, and exits the other side of the planet back into space in less than 20 minutes. It leaves behind a trail of damaged rock and a line of heat, but it does not trigger the end of the world. We survive because the bullet is too fast to kill us. But this speed is not guaranteed. Friction exists, even for strange matter. And eventually something is going to slow it down. If the Strangelet is moving fast enough, its journey through the Earth is brief. It enters the crust at a steep angle, punches through the mantle, grazes the outer core, and exits through the crust on the other side of the planet. The entire transit takes less than 20 minutes. To a geologist, this event is invisible. The hole left behind is microscopic, and the heat released is negligible compared to the natural heat of the Earth's interior. The Strangelet bursts out of the ground in the southern hemisphere and shoots back up into the sky. It escapes the Earth's gravity effortlessly, returning to the deep freeze of interplanetary space. It becomes a ghost. It was here, inside our home, inside the rock beneath our feet, but it left no trace other than a long, thin tube of fused silica that will never be found. This scenario, the through and through shot, is the best case scenario for humanity. It means that the Earth is transparent to the threat. We are being shot at, but the bullets are passing through us without detonating. We survive simply because we are not dense enough to stop the projectile. But this safety relies entirely on velocity. If the bullet is slow, or if it hits at a shallow angle, the physics changes dramatically. Friction begins to matter. And if the Strangelet slows down inside the planet, it does not leave. This brings us to a much darker hypothesis. We have been looking at the sky, worried about the Strangelets that might hit us in the future. We have assumed that the danger is an event, a collision that happens to us. But what if the collision has already happened? What if the Strangelet didn't pass through? Consider the sheer number of projectiles. Over 4.5 billion years, Earth has undoubtedly been struck by millions of these objects. While most were fast movers that exited the system, statistics dictate that some were slow. Some entered the atmosphere at the wrong angle or with the wrong energy. These slow-moving particles would not have the momentum to punch through the other side. They would lose their kinetic energy to the rock and the magma, slowing down with every kilometer of depth. Eventually, such a particle would lose enough speed that it could no longer escape Earth's gravity. It would stop rising toward the exit and begin to fall back down. It would oscillate back and forth through the center of the planet, losing more energy with each pass until it finally came to rest. This changes the nature of the threat completely. We are not just targets in a shooting gallery, we are a catcher's mitt. The Earth isn't dodging the bullets, it is catching them and keeping them. The reason these captured strangelets haven't destroyed the world yet is likely due to a fortunate accident of electromagnetism. Strange matter is expected to have a positive electric charge, just like the atomic nuclei of normal matter. In physics, like charges repel. This creates a natural shield known as the Coulomb barrier. When a slow-moving strangelet approaches a normal iron atom in the Earth's core, the positive charge of the iron nucleus pushes against the positive charge of the strangelet. At high speeds, this repulsion is irrelevant. The strangelet smashes through anyway. But at low speeds, the kind of speeds a captured particle would have, the repulsion acts as a brake. The iron atom bounces off the strangelet instead of merging with it. This electrostatic repulsion prevents the Ice-9 reaction from starting immediately. The strangelet sits there, surrounded by normal matter, but unable to touch it physically because of the electric field keeping them apart. It is suspended in a magnetic cage of its own making. The Earth's core essentially acts as a filter. It catches the strangelets, slows them down, and then stores them in a state of suspended animation. The monster is in the basement, but it is currently in a cage. Once the strangelet is captured and shielded by its charge, gravity takes over the long-term management of the object. Strange matter is billions of times denser than the iron and nickel of the Earth's core. In a liquid environment like the outer core, heavy objects sink. It is a simple buoyancy problem. A stone sinks in water, and a strangelet sinks in iron. The captured particle drifts downward through the molten metal, pulled relentlessly toward the exact center of the planet's gravitational field. It passes through the currents of the outer core and settles onto the surface of the solid inner core. Or, if it is heavy enough, it melts its way into the very center of the solid ball. This process is called gravitational sedimentation. It cleans the mantle and crust of any strange matter, concentrating all of it in a single, tiny region at the heart of the world. The strangelet stops moving. It sits at the gravitational center of Earth, effectively motionless, held in place by the weight of the entire planet pressing down on it. It is dormant. It is waiting. And it is not alone. If this process has been happening since the formation of the Earth, then the center of our planet is not just iron. It is a graveyard of captured monsters. Every slow strangelet that has hit Earth in the last 4 billion years has ended up in this exact same spot. They are collecting there, one by one, piling up like dust in a corner that never gets swept. This accumulation creates a terrifying situation. A single strangelet is safe because of its Coulomb barrier. 2 strangelets, separated by rock, are also safe. But gravity is constantly pushing them together, trying to force them into the same space. As the pile grows, the density of strange matter in the core increases. We are unknowingly walking on top of a growing reservoir of the most dangerous substance in the universe. The danger is that this reservoir is not static. The Earth is geologically active. The core spins, the magnetic field shifts, and the planet vibrates with seismic energy. We assume the ground beneath us is solid and reliable, but deep down, in the blind spot of our planetary awareness, we are hoarding a critical mass of contagion. We are packing gunpowder into the foundation of our house, confident that it won't explode because it hasn't exploded yet. But gunpowder doesn't need to be new to be dangerous, it just needs a spark. The danger of this accumulation is not linear, it is geometric. A single strangelet trapped in the core is stable because its positive charge keeps the surrounding iron atoms at bay. But strangelets do not repel each other indefinitely. Gravity is a relentless matchmaker. It drags every heavy object to the precise geometric center of the planet, forcing them into a confined space that gets smaller every year. Eventually, the density of strange matter in this trap becomes so high that the droplets begin to touch. When two strangelets collide, they do not bounce, they merge. They behave like drops of mercury on a table, snapping together to form a larger, single drop to minimize their surface tension. This merger is catastrophic for the safety of the planet because the physics of strange matter changes with size. As the drop grows larger, its gravitational pull increases, but its electric charge, the shield that kept it isolated, becomes less effective relative to its mass. The surface area to volume ratio drops. A large strangelet is not just a bigger version of a small one, it is a more aggressive one. It begins to overcome the Coulomb barrier that protected the iron core. The electric repulsion that acted as a brake fails. The iron atoms, which were previously bouncing off, are now pulled in by the sheer gravity of the growing sphere. The filter breaks. The Ice-9 reaction, which was paused for billions of years, resumes. The core of the Earth does not just get heavy, it begins to ignite. This resumption of hostilities might not happen spontaneously. It might require a push. A reservoir of strange matter in the core is essentially a loaded gun with a hair trigger. It is a metastable system, balanced on the edge of collapse, waiting for a sufficient jolt to overcome the final energy barrier. The trigger could be external. A massive asteroid impact on the surface of the Earth sends shockwaves deep into the planetary interior. We usually fear asteroids for the dust they throw into the atmosphere or the tsunamis they create. But a large impact rings the Earth like a bell. The seismic waves focus in the core, creating a momentary spike in pressure and temperature. This spike could be enough to push the strangelets together, forcing a merger that gravity alone hadn't achieved yet. In this scenario, the asteroid doesn't need to be a planet killer in the traditional sense. It just needs to be the spark. The impact might occur on one side of the planet, causing minor surface damage, but the shockwave travels through the mantle and detonates the strange matter bomb in the center. The death of the world would not come from the sky above, but from the ground below, minutes after the impact, as the core begins to collapse and the planet implodes. We are living in a house built on top of unexploded ordnance, and every time the ground shakes, we are rolling the dice. This theory of linear passage and core accumulation is not merely a paranoid fantasy, it has been tested. In the late 1990s and early 2000s, a team of geophysicists led by Eugene Herrin and Victor Teplitz at Southern Methodist University decided to look for the fingerprints of strange matter inside the Earth. They reasoned that if a strangelet passed through the planet, it wouldn't look like a normal earthquake. A standard earthquake is a point source event. Rocks break at a specific location, and waves ripple out in circles. A strangelet passing through the Earth at supersonic speeds is a line source event. It would create a shockwave along its entire trajectory, like a sonic boom moving through rock. This signal would look completely different on a seismograph. It would not be a single spike. It would be a sequential series of arrivals as the object tore through the planetary layers. Herrin and Teplitz accessed the massive database of the US Geological Survey, which records millions of seismic events from sensors all over the globe. They filtered out the noise, the plate tectonics, and the nuclear tests. They were looking for the impossible signal, a straight line of energy cutting through the chaotic noise of a shifting planet. They weren't expecting to find anything. Science usually assumes the null hypothesis, but the data disagreed. In 2002, the team published a report that should have terrified the scientific community. They found a set of seismic events that could not be explained by conventional geology. These signals did not originate from tectonic faults. They did not look like explosions. They had the distinct mathematical signature of a linear object passing through the Earth at a speed of roughly 300 to 400 kilometers per second. One event in particular, recorded on October 22, 1993, passed through the Earth's core and exited on the other side. The energy released was small, about a kiloton, but the geometry was unmistakable. Something punched a hole through the planet. The report was titled Seismic Search for Strangelets, and it concluded that while instrumental error couldn't be ruled out, the data was consistent with the passage of a compact, super-dense object. The scientific community largely ignored the findings. It is easier to blame a glitch in the sensor network than to accept that the Earth was sniped by a quark bullet. The report was filed away, but the sensors are still running, and the signals are still there in the archives. We have a record of the shots that missed. We have a record of the bullets that passed through. What we don't have is a record of the bullets that stopped, because the bullet that stops is the last thing a seismograph ever records. We are left with a disturbing picture of our planetary security. We are orbiting a star that drags us through a galaxy filled with the debris of dead suns. We are bombarded by invisible projectiles that act as seeds for a phase transition that would erase all matter. Our planet acts as a gravitational trap, collecting these seeds in its center, where they wait for a tremor to merge and ignite. The silence of the universe might be the result of this minefield. Civilizations do not just need to survive nuclear war or climate change. They need to be lucky enough not to live on a planet that catches a Strangelet. It is a game of cosmic roulette where the gun is pointed at the core of the world, and the trigger is pulled by random probability. But relying on luck is terrifying. Humans do not like to be passive victims of statistics. We like to take control. We like to understand the forces that threaten us. And in our arrogance, we have decided that the best way to understand the fire is to bring it inside the house. We are not content to wait for strange matter to hit us from the sky. We have built machines to make it ourselves, right here on the surface to see what happens when you poke the dragon. The most dangerous place on Earth is not a nuclear silo or a biological weapons lab. It is a 27-kilometer tunnel buried beneath the border of France and Switzerland. Here, at the Large Hadron Collider, LHC, and at its smaller cousin, the Relativistic Heavy Ion Collider, RHIC, in New York, humanity has built a machine designed to break the fundamental laws of stability. We are not satisfied with observing the universe as it is today. We want to rewind the clock to the first microsecond of creation. Inside these tunnels, scientists accelerate heavy ions of lead and gold until they are moving at over 99.9% of the speed of light. They smash these ions together head-on. The energy released in this collision is concentrated into a space smaller than an atom, creating a temperature of 4 trillion degrees Celsius. This is 100,000 times hotter than the center of the sun. In this extreme environment, the protons and neutrons of the gold atoms melt. They dissolve into the quark gluon plasma, a primordial soup that hasn't existed in the universe since the Big Bang. The goal of this experiment is to study how the universe formed. But by recreating the conditions of the early universe, we are also recreating its hazards. We are effectively building a little Big Bang in a bottle. The problem with bottles is that they can break. When we melt protons, we strip away the safety mechanisms that keep matter stable. We liberate the quarks, and once they are free, there is no guarantee that they will reassemble into the safe, familiar protons we started with. They might decide to build something else. The danger arises not during the explosion, but during the cooling. As the fireball of quark gluon plasma expands and cools, the quarks begin to condense back into particles, a process similar to water vapor turning into droplets of rain. Most of the time, they form normal matter. Pions, kaons, protons. But theory suggests that under specific conditions, the cooling soup can get stuck in a different configuration. This is called Strangelet distillation. As the plasma cools, the lighter up and down quarks evaporate first, leaving behind a residue rich in heavy, strange quarks. If this residue stabilizes, it forms a Strangelet. This object would be microscopic, negatively charged, and incredibly hungry. Unlike the neutral Strangelets from space that might pass through the Earth, a negatively charged Strangelet created in a collider is a nightmare scenario. It would not fall through the floor immediately. Its negative charge would attract the positively charged nuclei of the collider's own magnets and detectors. It would act like an atomic acid, bonding to the machine itself. It would eat the first atom of the pipe, grow larger, eat the next, and within minutes, the reaction would run away. The machine that created the particle would become its first meal, followed by the laboratory, the crust of the Earth, and finally the planet itself. We are essentially rolling dice with the phase transition of the vacuum, hoping that the soup always cools down into harmless broth and never into poison. This sounds like science fiction, but the fear was real enough to enter the legal system. In 2008, just before the Large Hadron Collider was scheduled to turn on, a lawsuit was filed in the US. District Court in Hawaii. The plaintiffs, Walter Wagner and Luis Sancho, sued the US Department of Energy and CERN, demanding an immediate injunction to stop the machine. Their argument was simple and terrifying. There is a non-zero probability that this machine will destroy the planet, and you have not proven it is safe. The media treated it as a joke, painting the plaintiffs as Luddites afraid of progress. But the lawsuit raised a valid ethical point about existential risk. In standard risk assessment, you multiply the probability of an event by the magnitude of its consequences. If the probability of a plane crash is low, but the consequence is death, you take precautions. In the case of the collider, the probability was calculated to be infinitesimally small, perhaps 1 in 50 million. However, the consequence was infinite. It was the total annihilation of all biological life and the loss of the future. When you multiply a small number by infinity, you still get infinity. The logic of the lawsuit was that no amount of scientific knowledge, no matter how many Higgs bosons we find, is worth a microscopic fraction of a % chance of deleting the human race. It was a trial of curiosity versus survival. The scientists argued that the risk was theoretical. The plaintiffs argued that until it is proven impossible, it is a game of Russian roulette where the gun is pointed at the entire species. CERN took the threat seriously enough to commission a formal safety report, the LSAG review. Their primary defense relied on an argument from nature. They pointed out that Earth and the Moon are constantly bombarded by cosmic rays, high-energy particles from deep space that slam into the atmosphere and the lunar surface, with energies far greater than anything the LHC can produce. The argument went like this. Nature has been running this experiment for billions of years. High-energy collisions happen on the surface of the Moon every second. If these collisions could create strangelets that destroy planets, the Moon would have been converted into a sphere of strange matter a long time ago. The fact that the Moon is still there proves that strangelets are not produced in these collisions, or if they are unstable and harmless. This defense, known as the cosmic ray argument, seems ironclad. It suggests that human arrogance is misplaced. We are too weak to break the universe. Our biggest machine is a toy compared to the natural accelerators of the galaxy. The scientific community breathed a sigh of relief. The lawsuit was dismissed on jurisdictional grounds, and the machine was turned on. But there was a flaw in the logic, a subtle kinematic trap that the safety report glossed over. The flaw lies in the difference between a bullet hitting a wall and 2 bullets hitting each other. In nature, cosmic rays are like fast bullets hitting a stationary target, the Moon. The energy of the collision is massive, yes, but the momentum is all moving in one direction. If a strangelet is created on the Moon, it is born moving at nearly the speed of light, relative to the surface. It punches through the Moon and shoots out into space before it can slow down and eat anything. It escapes. The LHC is different. It is a collider. It fires 2 beams at each other head-on. When they smash together, their momenta cancel out. The center of mass is stationary relative to the lab. If a strangelet is created in the LHC, it is not born moving at the speed of light. It is born at rest. It floats there, hovering in the pipe, with 0 velocity. This is the critical difference. A strangelet created on the Moon flies away. A strangelet created in Geneva falls down. Gravity grabs it instantly. It falls through the bottom of the detector, hits the concrete floor at low speed, and begins to feed. The natural experiment on the moon does not test the safety of the collider, because the conditions of capture are completely opposite. We created a unique trap that nature does not replicate. A place where a monster can be born and immediately served a meal instead of being flung into the void. The fact that the moon is safe tells us absolutely nothing about whether we are about to commit suicide. The decision to turn on the machine comes down to a terrifying calculation of odds. In 2008, a few physicists, including Nobel laureate Frank Wilczek, admitted that the chance of creating a dangerous Strangelet was non-zero. They estimated it might be 1 in 50 million. To a rational mind, those odds look like safety. You would happily board a plane if you were told there was only a 1 in 50 million chance of it crashing. But this is a category error, because the stakes are not the same. In a plane crash, you lose a few hundred lives. In a Strangelet disaster, you lose the planet, the species, and the entire future of biological evolution. This is a variation of Pascal's wager. If you bet against the existence of the Strangelet and you win, you gain a few terabytes of data about the early universe. If you bet against it and lose, you lose everything that has ever existed. The potential gain is finite and academic. The potential loss is infinite and absolute. Standard game theory says you should never take a bet where the downside is infinite, no matter how small the probability. Yet, as a species, we took the bet. We placed the chips on the table, spun the wheel, and pressed the beam on button. We won that round. The Earth is still here. But the nature of probability is that winning once does not guarantee you will win again. We played Russian roulette with a revolver that has 50 million chambers and 1 bullet. We pulled the trigger and heard a click. Our reaction was not relief. It was to assume that the gun wasn't loaded. This recklessness offers a compelling, if depressing, solution to the Fermi paradox. We look at the stars and wonder why we haven't heard from any advanced civilizations. We assume they must have destroyed themselves with nuclear weapons or bioplagues. But those are survivable events. Life tends to crawl back from the brink of war. A Strangelet disaster is different. It is a sterilizing event that leaves nothing behind but a hot, silent sphere of quarks. The collider trap suggests that curiosity is the ultimate filter. Every intelligent species eventually discovers the structure of the atom. They all build machines to smash those atoms apart to see what's inside. And because the laws of physics are universal, they all eventually build a machine powerful enough to trigger the phase transition of the vacuum. It is possible that the galaxy is a graveyard of ambitious physicists. The silence we hear is the silence of civilizations that were too smart for their own good. They didn't die because they were aggressive or warlike. They died because they were competent. They built the perfect machine, ran the perfect experiment, and achieved the perfect ground state, effectively deleting themselves from history the moment they turned the key. We are currently standing at that same threshold, convinced that our math is better than theirs. You might think that knowing this risk would make us stop, but we are doing the exact opposite. CERN is currently planning the successor to the LHC, the Future Circular Collider, FCC. It will be 4 times larger and 7 times more powerful, designed to smash particles with energies that make the current experiments look like child's play. We are building a bigger gun because we want to see smaller particles. This drive is not merely stupidity, it is a compulsion. We are like moths circling a flame, drawn to the light of knowledge even if it burns us. There is something in the human spirit that refuses to leave a mystery unsolved. If there is a door in the universe labeled "Do Not Open," we will spend billions of dollars to build a battering ram to open it, simply because we have to know what is on the other side. The FCC represents the next spin of the roulette wheel. We are increasing the energy, which increases the probability of creating the very monsters we fear. We are pushing closer to the theoretical limits of stability. It suggests that intelligence is a self-correcting anomaly. The universe allows us to evolve just enough to build the machine that fixes the mistake of our existence. And this brings us to the final philosophical horror. The universe wants us to push the button. If we step back from the machinery and look at the thermodynamics, the situation becomes almost spiritual. The universe is not a static place, it is a flow. It flows from order to disorder, from high energy to low energy. A river flows to the sea not because it chooses to, but because the sea is lower. The desire of the water is to reach the lowest point and stop moving. Strange matter is the sea. It is the lowest point on the energy map of physics. Ordinary matter, the protons in your body, the burning of the sun, the structure of DNA, is the river crashing down the mountain. It is noisy, turbulent, and energetic. But it is trying to get to the sea. The conversion of Earth into a strange star would not be a disaster for the cosmos. It would be a resolution. It would be the system finally finding peace. This means that the forces of nature are aligned against us. Gravity wants to crush us. Entropy wants to unravel us. The strong nuclear force wants to bind us into a featureless lump. Our existence is a temporary delay in this process. We are a dam holding back the river, and the pressure is building every second. The universe is pushing toward the nirvana of the ground state, a place of perfect, eternal silence where nothing ever happens again. This perspective flips the script on what it means to be alive. We usually think of life as the point of the universe, the climax of creation, but physics suggests we are a glitch. We are metastable, a state that shouldn't exist but persists because of a bottleneck. We are a bubble of foam floating on a calm ocean, terrified of popping. To be alive is to be in a state of constant rebellion against the laws of physics. Every time you eat, you are fighting entropy. Every time you heal a wound, you are fighting decay. Every time you build a city, you are fighting the tendency of things to fall apart. We are the anomaly. We are the high-energy freaks who refuse to settle down and become strange matter. This makes our existence tragic, but also heroic. We are not the favorites of the universe, we are the resistance. We are maintaining a complex, fragile shape in a cosmos that prefers simple, solid spheres. We are holding the sky up with our bare hands, refusing to let it collapse into the lower energy state. The fact that we have survived for this long, that the bubble hasn't popped in 13.8 billion years, is a testament to the stubbornness of complexity. When you realize that you are the anomaly, the horror shifts. You stop being afraid of the dark and start realizing that you are the light that the dark wants to extinguish. The Strangelets, the Neutron Stars, the collapsing vacuum. They are not monsters hunting us. They are the immune system of the universe trying to cure a fever. We are the fever. We are hot, chaotic, and loud. We spread, we consume, and we complicate things. A universe made of strange matter is cold, organized, and simple. By existing, by thinking, by building colliders, we are irritating the void. We are a localized violation of the trend toward nothingness. This is why the sky is silent. The silence is the natural state of a healthy, dead universe. The noise we make is the symptom of our disease, but it is a beautiful disease. It is the only time the universe gets to experience itself. Without the anomaly of life, the cosmos is just a blind machine grinding rocks into dust forever. We are the only part of the machine that knows it is a machine. So, what do we do with this knowledge? If the universe is a trap and the laws of physics are waiting to erase us, should we just give up? Should we lie down and let the strange matter take us? The philosopher Albert Camus proposed a different solution. He imagined Sisyphus, the king condemned to roll a boulder up a hill forever, only to watch it roll back down. It is a pointless, hopeless task. It is the definition of absurdity. But Camus concluded, one must imagine Sisyphus happy. Why? Because the act of rolling the boulder is an act of rebellion. Sisyphus knows he cannot win. He knows gravity will defeat him. But he pushes the rock anyway. He pushes it to spite the gods. He pushes it because the struggle itself gives him dignity. We are Sisyphus. The boulder is our existence. The hill is the energy curve. Gravity is the Strangelet waiting at the bottom. We know that eventually the rock will roll down. Eventually the sun will die, or the collider will fail, or the vacuum will decay. But we push, we build, we love, we explore. We do it not because we expect to win the game of thermodynamics, but because playing the game is the only way to insult the empty void that wants us to stop. This defiance gives us a purpose. If we are the only anomaly in a galaxy of dead matter, then we have a duty to protect the glitch. We are the guardians of the flame. If we allow ourselves to be destroyed by a stray Strangelet, by a collider accident, or by our own apathy, we are not just ending the human story. We are allowing the universe to go blind. We are the eyes of the cosmos. A strange star cannot appreciate its own density. A black hole cannot marvel at its own event horizon. Only we can do that. If we vanish, the universe returns to a state of meaningless interaction. It becomes a movie playing in an empty theater. Therefore, our survival is not just a biological imperative, it is an ontological one. We must be careful. We must treat our technology with the respect due to a loaded weapon. We must watch the skies for the invisible bullets, and we must continue to push the rock up the hill, knowing that as long as we are pushing, the universe is alive. Consider the alternative. Imagine the perfect universe that physics craves. A universe where every star has collapsed into a strange star, where every planet has been converted into a stable sphere, where all the unnecessary empty space in atoms has been removed. It is a universe of absolute efficiency. It is crystalline, permanent, and indestructible. It will last forever, unchanging, until the end of time. It is also a hell. It is a frozen, static hell where nothing new can ever happen. There is no art, no science, no conversation, no surprise. It is a graveyard with the lights left on. That is the paradise that strange matter offers. Our messy, dangerous, metastable world is superior because it is flawed. The empty space in our atoms allows us to move. The instability of our chemicals allows us to think. The risk of death gives value to life. We should not envy the diamond. We should pity it. It is perfect, but it is dead. We are broken, but we are free. The next time you look at an apple on your desk, remember what it really is. It is a miracle of suspension. It is a cluster of atoms fighting a desperate war against gravity and the strong nuclear force, holding its shape against a universe that wants to crush it into a perfect, dead sphere. It is a temporary victory. You are the same. You are a walking anomaly, a collection of high-energy particles that refuses to be simplified. The danger is real. The Strangelets are out there, invisible bullets flying through the dark. The colliders are running, rolling the dice with the vacuum. The trap is set. But you don't have to be afraid. Fear is for things that expect to be safe. You know the truth now. You know that safety is a lie. So take the risk. Live your life with the intensity of a flame that knows the wind is blowing. Do not let the universe bully you into silence. And do not let the algorithms bury this signal. We are building a network of observers here. A group of minds willing to look at the abyss without blinking. If you want to keep this channel open, if you want to ensure the signal continues to broadcast against the silence, you know what to do. Subscribe to the frequency. Turn on the notifications. It is a small act of defiance, a way to tell the system that there is still intelligent life in this sector. I also want to know your verdict. We discussed the risk of the Large Hadron Collider and the silence of the galaxy. Do you believe we should stop the machine to save the planet? Or should we push the button and risk everything for the sake of knowledge? Is it better to be safe and ignorant, or dangerous and wise? Leave your answer in the comments. Leave a trace of your thoughts before the data is overwritten. Propose the next sector of reality we should deconstruct. The universe prefers the quiet of the ground state. It wants you to be a passive, silent observer. Don't give it that satisfaction. Be loud. Be complex. Be the glitch. And whatever you do, keep pushing the rock. Because the moment you stop, the moment you blink, the gravity wins. With you was acronium,